This is Lesson 7 in Unit 5 of Algebra 2. As we saw in the previous lesson, the solutions to ax squared plus bx plus c equals 0 can be found with the quadratic formula. The portion under the radical right here is called the discriminant. So if someone has discriminating taste, it means they're able to distinguish between things. So let's see if you have what it takes to be a discriminating algebraist. So I'm going to show you a few problems that I came across while doing the quadratic formula the other day, and I want you to tell me which ones you think have real solutions and which ones do not. So I got it down to this. So there's a question. Does that have a real solution, you think? How many of them? Well, we could use a calculator, right? I mean, is that a real number? Okay, well, it's 7 plus the square root of 11 over 2. That's a real number, right? That's a real number. And then the other answer would be with a minus. Now, it's not a rational number, right? This decimal goes on forever without any repeat. It's not rational, but it's real, right? The square root of 11 is in between 3 and 4, right? Okay, another one I was doing, I got this. I got 4 plus or minus the square root of negative 3. So is that real or not? Why is it not a real solution? Right, and we could try to do that. So here, 4 plus the square root of negative 3 over 2. And you'll see I get an error, non-real result, right? So that's no. This was, how many solutions did this have? This had 2, right? Because I had to add the square root of 11 and subtract, give me two different numbers, right? So that was 2 solutions. This was none. And I'm not saying the solution was 0. I'm saying 0 real solutions. The number of them were 0. And then I did this. I got that for my answer. What is that? 5 plus or minus the square root is 0. Well, we got to think, is that a real number? Can I square root 0? Yeah, I can. I get 0. But how many different solutions do I get here? I have one answer where I have to do 5 plus 0. That's 5. And the other one is 5 minus 0. That's also 5. So I only get one real solution. So let's go back and look at the quadratic formula. Everything about whether or not I got a real solution or not was dependent on what was underneath this square root. Nothing else mattered except for if I have a negative inside this, then I'm going to get no solution, right? So it's this that has all the power to determine whether or not I have a solution. And so therefore we say that if b squared minus 4ac is a negative number, right? That means negative. If b squared minus 4ac it results in a negative value, will I have any solutions? No. Then we'll have no real solutions. But if it actually ends up equaling exactly 0, 0 is a funny number. Because the square root of 0 is 0. And then you have to add and subtract 0. And adding 0 and subtracting 0 doesn't change anything. So it has one real solution. Finally, if b squared minus 4ac is bigger than 0, then we know we're going to get 2 different numbers when I take the square root. One I'm going to add, another I'm going to subtract. So it's going to have 2 real solutions. There's one more thing we can say. If b squared minus 4ac is a positive perfect square, 0, well, not 0, 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, something like that, right? Then the equation is factorable. Because only equations with rational solutions are factorable. And every factorable equation has rational solutions. So let's see how to do this. We're going to use the discriminant to classify the following equations based on the number or type of solutions. Quite often, we are interested in the type of solutions and the number of them, but we're not actually interested in the solution itself. This has ramifications well beyond algebra, pre-calculus, and calculus. We are interested not necessarily in the answer, but in how many there are and of what type. So let's do the discriminant. B squared minus 4ac. So that's 5 squared minus 4 times 1 times a negative 6. So that's 25. Got a minus and a negative makes it a plus. 24, 49. I just plugged in for b squared minus 4ac. All right, so because this is a positive number, we're going to have two real solutions. So we're going to say two real and rational solutions because it was factorable. And in fact, you can see that it is factorable. If the equation is factorable, the discriminant will be a perfect square. Let's take a look at the next one. Again, we're just classifying it with the discriminant. B squared minus 4ac. So b squared minus 4 times 1. That's a 9 minus 16. Was that negative 7? Okay, so that's what's under the square root is a negative 7. Can I square root a negative? No. So 0 real solutions. Let's take a look at C. B squared minus 4ac. So that's 5 squared minus 4 times 2 times 3. So 25 minus 24. Eight times 3 is 24, right? So that's 1. So 1 is a perfect square. So we have two real and rational solutions. If this was not a perfect square, we would have irrational solutions. Okay, so what I want you to do, please, is practice categorizing these equations here according to the number of solutions, and if they're real, categorize them as rational or irrational. All right, let's see how we did here. We're going to classify these, so we use the discriminant. So that's negative 3 squared minus 4 times a negative 1 times 8. So that's 9 plus 32, which is 41. 41 is not a perfect square. The square root of 41 is a real number, but it's not rational. So we have two irrational and real solutions. Totally real, just not rational. All right, b squared minus 4ac again. 8 squared minus 4 times 1 times 10. That's 64 minus 40, it looks like, which is 24. So 24 is a positive number. So we know they're real. There's irrational and real solutions. Right. It's all about an irrational number is simply a number that, like pi. Pi is the most famous irrational number, known because it just keeps going, right? Well, it turns out that that's actually quite common in numbers. The square root of 24, for example, is irrational. The number doesn't stop there. It keeps going, and then it would go even further than that if I was to make a calculator do it. That's what irrational means. The square root of every number between 16, the square root of every integer between 16 and 25 is irrational. So the square root of 17, irrational. 18, irrational. 19, irrational. Etc. All the way up to 24, irrational. But as soon as I hit 25, boom, gives me exactly 5 for an answer. Because it's rational. Okay? You can get decimals to the square root. For example, if I take the square root of, let's see here, 3 point, see here, 0.36. Can I think of a number that times itself gives you 0.36? Yeah, 0.6. So you can't have decimals. It's just they still have to be perfect squares. All right, let's try this one. B squared minus 4ac. So this is negative 10 squared minus 4 times 1 times 8. So it's 100 minus 32, which is what, 68? All right, let's do this one. Negative 6 squared minus 4 times 1 times 9. That's 0. 1 real and rational solution. I don't know if earlier I said real and rational when that happened, but it will be real because the square root of 0 is a real number, and it will be rational because the square root of 0 is also a rational number. All right, let's take a look at this. We're going to express the values of c that result in the following equation having 2 real roots. So this is where we're solving for a value of c that makes us have 2 real roots. What I'd like to do is I'd like to look at it graphically first. So let's just pull up a graphing calculator here and see if we can't get an idea of what this question is asking us to do. Well, we want to express what that number would be technically using with like an inequality. So I have x squared plus 4x plus c, which if this calculator will load. No, see that's not at all what you're supposed to do. X squared plus 4x plus c. X squared plus 4x plus c. So we know that the solutions to this equaling 0 are where we're crossing the x-axis. Let me make this a little darker here. So these are real solutions because these points of intersection are real. You could probably play with this enough to know that getting them to be rational is kind of rare, actually. You have to get it just right. But if I go up too high, the graph is gone. It's off of the x-axis, and this no longer has any real roots. If I go, then I have to wait till I go back down low enough for it to. And because it's a parabola opening upward, there's always going to be 2 solutions as long as I keep dragging this c downwards. So that's what we're going to expect to find. Let's see how that works out mathematically. So we know that b squared minus 4ac to have 2 real roots has to be a positive number. That's what having 2 real roots means. It means b squared minus 4ac is greater than 0. My b is 4, so I'll call that 16. My a is 1, and I don't know c. I'm going to solve this as just a linear inequality. So what I get is c is less than 4. to solve the equation. I did not. I divided it by 4. All values less than 4. All right, so for this practice problem, I want you to find the largest integral, which means no fractional part, largest integral value possible for a, so that the equation has 2 real roots. So I want a to be as big a number, as big an integer value you can get, where you still get 2 real roots. Don't guess and check. Use the discriminant. Okay, so in order for this equation to have 2 real roots, the b squared minus 4ac must be greater than 0. So 6 squared is 36, a, and then c is 4. So I have 36 minus 16a must be greater than 0. I'll subtract 36 from each side and divide by a negative 16, so I have to flip the sign. So where does b squared minus 4ac appear in the quadratic formula? It appears underneath the square root. So if this is negative, I'll have no real solutions. So in order for me to have 2 real roots, it has to be positive. If it's 0, it gives me only 1 real root. Now I can reduce this 36, I can divide both these by 4, making this 9 over 4. Which, if you divide it, is 2.25. Which is telling me that the biggest integer value a could be is 2. So that's the answer, 2. 2 is the largest value of a that we can have that's an integer and still have 2 real solutions. All right, on practice 7.3, it says what 2 values of b would result in the, in the following equation having only 1 real root. So think about what do we know about the discriminant that causes it to have only 1 real root. It's right here on page 31. In order to have only 1 real root, the discriminant b squared minus 4ac has to be equal to what? It has to be equal to 0. So b squared minus 4 times 2 times 8 gives me b squared minus 64. Which is interesting because now I'm solving a quadratic equation to solve a quadratic equation, in a way. But this is a difference of 2 squares, b minus 8, b plus 8. So it gives me 8 and negative 8. And we know that. We know that if this is going to be a perfect square trinomial, there's 2 different values that this could be. One positive, one negative. 8 and if we put an 8 in there or a negative 8 in there, we will get only 1 solution because it'll be a perfect square trinomial. All right, for practice 7.4, we're going to just take a nice mixed review of some problem types. You always want to work them together? All right, so here we have one that's factored. I get excited when I see something factored, but it has to be equal to 0. It is, right? So because it's equal to 0 and it's factored, we have very little work to do. We just set each factor equal to 0. Okay? Remember, when solving by any suitable method, you want to factor if possible. Nothing's faster and easier. Set each factor equal to 0 and solve. So 1/3 and negative 5 over 2. It was right there. Okay, on the next one, letter B. If you can factor, factor. It's always easier to factor. And you can always factor when there's nothing but x's, right? Because I can factor out a 7x. X minus 3 equals 0. So set each factor equal to 0. Turns out the 7 doesn't matter. It's just x equals 0 and x equals 3. Don't lose this answer. A lot of people get that one and for some reason don't get the 0. All right, for letter C, same thing. It's always easier if you can factor. But you got to set it equal to 0 first. We have to have it set equal to 0 to use the quadratic formula as well. So this looks like a perfect square trinomial. Is that a perfect square? Is that a perfect square? Is that twice their product? 3 times 1 is 3 times 2 is 6. Perfect. That is 3x and 1, and you take the sign in the middle. This is the situation. If we did the discriminant here, we would get a discriminant of 0. You'd have 36 minus 36 is 0, because we're only going to get one solution. Set that factor equal to 0, and you get 3x equals 1, so x equals 1/3. All right. X squared minus 8x minus 9 equals 0. Try that one. If you can factor, factor. All right. Hopefully you realize that this is factorable. Because 9 and 1 subtract to 8. Make it a minus 9 and a plus 1, so you get a negative 9x plus 8x. 1x is negative 8x. Then set each factor equal to 0. I get x equals negative 1 and x equals positive 9. All right, next I have x squared minus 18 equals 0. Okay. It's not factorable because this is not a perfect square. But you don't want to use the quadratic formula unless you have to. You can use square roots. So just solve for the x squared term and take the plus or minus square root of each side, giving you x equals plus or minus the square root of 18. 18 is not a perfect square, but we can simplify the radical. And I can pull out a pair of 3s with the 2 left over. So it's x equals plus or minus 3 times the square root of 2. All right, on letter F. It's already factored. That's awesome, but it's not equal to 0, so it doesn't do us any good. We have to set it equal to 0 and factor later, if possible. So what I'll do is I'll distribute the x, making it 7x minus x squared equals 12. I want to set it equals 0, but I don't like a minus for the x squared. So let's move everything over to the other side. Making it positive x squared minus 7x plus 12. Now, is there anything that multiplies to 12 and adds to 7? Well, yeah. 4 and 3. So that's so much better. They're going to have to both be the same sign because the 12 is positive. And a negative 4 and negative 3 make negative 7. So that's great. Always easier to factor. X equals 4, x equals 3. All right, last one on G, we have x squared plus 6x equals 1. Set it equal to 0, try and factor. Doesn't look like it's going to factor, though. Is there anything that multiplies to 1 and subtracts to 6? No. So we have to use the quadratic formula. X equals opposite b plus or minus the square root of b squared minus 4 times a times c all over 2a. So that's negative 6 plus or minus the square root of 36. Got a minus with a negative, so it'll be a plus 4 all over 2. So that becomes the square root of 40, which we might be able to simplify. I can pull out a 2. So this is negative 6 plus or minus 2 times the square root of what was left over was a 2 and a 5. So I multiply them back together to get 10. And then because I can divide that number and that number by the same thing and divide that number, I can divide all three of these numbers by 2. Don't touch the number inside the radical. You have to have a number on the outside to do this. If you don't get something outside, you just stop. Negative 3 plus or minus 1 root 10. So those are my solutions.